So I thought I'd included some of the slides that we have presented in the Merga paper, Merga last year. And the reason why I developed this section C data analysis process is if you use this example from the Australian Wi-Fi paper, we have 625 responses. And out of those, 143 are responses that appear more than once, so it's quite easy to sort them. But the remaining 450 responses, they're either empty, pardon? Right. So the remaining responses, they're either empty, or for the 395, they're unique responses, means each one of them needs to be sorted individually, manually. So that could take a lot of time. Then I thought, is there a way to automate the process? So there is a process, and I'll just give you an overview of how that process works. So if you look at the responses for the 625, the top response was knowledge. There was 11 of them for the top response. The second top response was effort and brain. They both had 9, which meant the other responses had very low frequency. So there were about 390 responses that you need to manually sort. And when I did the 4-step data analysis process, we sorted all these responses. For example, in the 11 on the right-hand side for knowledge, this is the ones that was sorted if you didn't need the algorithm. But the others, such as the capital knowledge, the knowledge about math, on the left side, the incorrect spellings of knowledge, and that the teacher can give kids all the knowledge, they will be sorted through this 4 steps. This is the summary of what the 4 steps are. So the first step would be, you need to identify the top 30 responses based on the frequency count. And for the second step would be for each of the top 30 responses, you need to search this word or phrase in the remaining responses and allocate the same group. So based on the frequency count, we have 30 words or phrases. Most of it's our word, but there could be 1 or 2 that are short phrases that are commonly appear. And if this word appears in the remaining response, it will be grouped to the same group. The next step is using Levenshtein distance. It is a type of edit distance that basically looks at how closely the 2 words are. The parameters I set is that they have to be at least 3 letters length or more, and they can only be 1, 2, or 3 letters difference. These differences can be either an addition of a letter, deletion of a letter, or changing a letter. And in subsequent slides, I'll show you how these differences would look. By after step 3, I did write the number, we have sorted about 36% of the responses. It may sound a bit low, but you have to keep in mind, most of these responses that we collected are very different. They're qualitative data, so they are very wide and dispersed. They give us a wide range of values. And out of these unsorted responses, so we have 328 responses that are unsorted. 15 of those have 2 counts. The remaining 310 responses only have 1 count. And none of these unsorted responses after step 3 really represent items that have a big value. They have a low frequency because the top 30 responses have already been allocated. And in order to get through the 4-step analysis, you need to first tabulate the frequency count. So you have a look at the identical responses. Then you count the missing responses to record it. So for our Australia data, there were 87. The Hong Kong data had about 100. And then you clean the data. So if it's just English-based responses, you need to clean the ones that are obviously not informative, such as 20 letters that are the same, or just equal minus signs, or some of them even have the survey link. And if it's multiple language responses, you'll need to code each language differently because some languages might follow a different system and not all steps are applicable. For example, for any English type languages, and I believe for Turkish, for example, you can use all 4 steps because Levenshtein distance is likely to work. But if you use like a character system response, such as Chinese language or Korean, step 3 Levenstein distance is not likely gonna work because each change in the character in Chinese is counted as a Levenstein distance of 2. And it doesn't matter whether you change from one letter, one character to another. It can be any of the 1,000 character change, and it treats as the same change. So for some of the languages, you will need to rely on step 1, 2, and 4. And let me show you. So I'll have an example here, which might be easier for you to visualize what are the changes. The original data has, I say, 600 responses if you look at the left side. And the first step you will need to do after the cleaning is you have the frequency of the responses, and then you order it by the highest frequency to lowest. Then the algorithm would then allocate the top 30 responses based on frequency in step 1. And in our next paper with the Hong Kong data, we will be releasing the algorithm, such as the command that we use. So you can use any statistical program as long as it has a coding base and it has some sort of Levenstein distance command. But if you use like a language such as Chinese or Korean, you don't even need to use the Levenstein command. You just need to have a coding capability statistical program. So after it's sorted the top 30 response, which here we only use the top 10, you move on to the next step, which is step 2. So in step 2, it basically searches from top to bottom. In cake, it has the highest frequency. So in the next step, it searches for any responses in the remaining 600 response for the word cake. If it has this response, it will allocate it to the same group. For example, cupcakes. It used to be number 8 in the frequency. It was the 4th most common one. Now it's allocated to the same group because this word appears in later steps. And it goes down to the list. For example, apple, it was in group 7 because it was the 7th most common response with 5. Then it searched for the remaining response and found apples. Apple appears in apples, so they are allocated to the same group. So step 2 only looks for the whole data set and find anything that is identical in the word in the top 30 to the remaining response. And it only goes from top to bottom. So the most frequent one to the less frequent one. You will notice that banana and bananas on these 2 lines are not allocated in this step. It's because capitalization is treated as a separate response. So that would be fixed in the next step. In step 3 is based on Levenstein distance. As mentioned earlier, this is only applicable to English language-based responses. If it's character-based, it's not going to be very applicable because it won't pick up the differences. So step 3, the parameter that we set is anything that has at least 3 letters and are within 3 edits. So these edits can be capitalization, adding a letter, deleting a letter, or changing a letter. For example, yum was in our group 2. It had 10 count. So when the algorithm went and searched for the remaining response, it picked up yummy. The first change would be changing the capital Y to lowercase. Then it adds another M, then it adds another Y. So this is within 3 Levenstein distance, and they will be allocated to the same group. Like earlier, banana, in step 2, they were in separate groups. But in this step with Levenstein distance, changing from a lowercase b to a higher case b is 1 Levenstein distance. Adding the letter S is the 2nd Levenstein distance. So this has a Levenstein distance of 2. They will be allocated together. Similarly with the example of tasty and apples. So at this step, the algorithm uses the Levenstein distance. You can customize like how many letters the word needs to be. You can also customize the Levenstein distance, like how similar the words need to be. For the data that in Australia, 3 Levenstein distance is appropriate. Anything shorter is too restrictive. You can only change 1 or 2 letters or add 1 or 2. It doesn't have a lot of scope. If you have a Levenshtein distance that's too large, then you might have a lot of random words that change. For example, good and another 4-letter word could be grouped in the same group if you have a Levenshtein distance of 4 and at least 4 letters. So these are the things that you have to consider if you just use this algorithm. You have to suit it and adjust it to the language characteristics. The final step is semi-automated. So unlike the other 3 steps, once you set out the algorithm, it's basically about 20 lines. Setting up the algorithm took a lot of time, but once you follow the methodology from the Australia Wi-Fi analysis paper, you can run it quite easily. It's 20 lines. You run it, it takes about 10 seconds. It would sort 36% to 40% of your data in one go. And step 4, it is semi-automated. So we use the code book. Basically, it is like the 50 common values or responses that you would expect to get in these Wi-Fi responses. And the code book, it wouldn't say like cupcake or yum, but it would say, for example, in the smart list group, you'll have words such as smart, clever, intelligence, brain. Or in the content knowledge group, you might have mathematics, content knowledge, content. You will have these keywords. So you just put in this into the algorithm and they will group anything that is unsorted and contains these words as one group. You will also group anything that's already in the top 30 of the same values into the same group. For example, tasty and delicious. There isn't going to be any algorithm that would really group these two as the same group based on the word itself. So you will need an algorithm that recognizes these capture the same value and put them together. Same with nutritional and nutrient. While they are not allocated in previous steps, because most of the responses are individual, and you will need to group these in a way that's recognizing their similar groups, but they aren't spelled identical. They won't be picked up by the algorithm. So these are the 4 steps that I have used. And after these 4-step analysis, you'll see that the responses are allocated by group and count. So in the first group, you will have like cakes, cupcakes, and then the Wi-Fi data will be like smartness, fun, effort. Then we calculate the number of responses in the groups. And then you will reassign the group numbers, because now that you have gone through the 4 steps, especially after step 4, some of the groups might be larger or smaller because of the addition of the rare and low frequency responses. Finally, you'll have your group number, and you can assign these group numbers by the values that they capture. Yeah, so I'll just quickly mention about for the Chinese responses. So everything is the same, except there's no step 3 because Levenshtein distance is not applicable for character system responses. And I will put it back on this step in case anyone has any questions about it. Does anyone have any questions about the 4th step? Oh, hello?
I'm still thinking, Cindy, my head's...
Oh, sorry.
I mean, I'm always fascinated to hear about large-scale analysis, and I think you guys have a special gene for this. And I remember seeing this at Murga too.
Yes, yeah. So we have implemented this in the Murga one for the purely Australian data, and right now we are doing it for the Hong Kong one, which also has the Chinese data. So in addition to not having step 3, when you have 2 languages, the way I did it is I follow one language, analyze it, then do the second language and analyze it to groups. Then after you have equated both one into groups, then you set the groups together, merge the groups together. So you only need to translate 50 group names which captures the value, rather than translate like 1,000 lines of responses. That will largely reduce your workload and time.
Cindy,
Yeah.
thanks for sharing. Do you want to explain a little bit more about the Levenstein distance to everybody? So perhaps with an example.
Yes. Yes.
Yeah. And in relation to that as well, how do you reconcile, for example, the responses GOOD, which is good,
Yeah.
to GOD, which is God, which they are different, and even though they have a Levenstein distance of 1, and GOF, which is goof.
GOF, yep. Okay. So Levenstein distance is a linguistic measure. It basically says how different the two responses or two words are. So a Levenstein distance is anything that can be a deletion. So you're removing letters, your addition, adding letters, or changing letters. It's borrowed from DNA replication. In DNA, there are 4 types of replication, and 3 of them are applicable to letter changes. And WT asked from good GOD to GOD, it is a Levenstein distance of 1 because you're changing from GOOD 4 letters and you're removing 1 letter and it becomes GOD. And when it's changing from good to GOF, you're changing 2 letters. So first you're removing one of the O's, that's 1 Levenstein distance. Then you're changing the D to an F, so that's a Levenstein distance of 2. And using this algorithm, both of these, all 3 letters, all 3 responses will be grouped to the same response group. So it does have some manual sorting to be done, such as this example, the goof, God, and good. They do not really capture the same value. So in step 4, when you manually add the groups, you need to also inspect within the group. This is a lot easier than if you did a big list of 600 or 1,000, because you're sorting it through different entries. Whereas now you're sorting through a group, which usually is a size of between 10 to 15. So you can quickly glance through and see, oh, is there anything that doesn't belong here?
Thanks. So I guess a lot will depend on the code book that you have put together, and I believe that the code book will be available for anyone who is also analyzing section C, especially the English language. And it'd be good, when we distribute and share the code book around, that the different teams can also add new things that they have come across into the code book so that everybody else can benefit later.
I think definitely the code book has made it a lot easier, because when the Australian data was analyzed, the code book was being developed. When the Hong Kong data was analyzed, you can refer back to the code book. So step 4 became a lot quicker. Step 1, 2, 3 is quick to set up. Step 4 takes a bit of a nuance. But with code book, it is a lot quicker.
Cindy, I have a question.
Yes.
Sorry about the screaming kids in the background, if you can hear them.
I can't hear it.
I've locked myself in the bedroom. Do you import this into SPSS? Is that what you're doing? Or how are you running the algorithm?
So that's a good question. So the program I use to run this is called Stata. I use the version 13, not the latest, but it still is powerful. It's because each license, there's not much change and it's quite expensive. So we have bought the edition for version 13. And you can use any statistical program that has a coding base. I haven't coded in SPSS. From my understanding, most people click the buttons. I would not
recommend code. Yeah, so you can copy and paste a letter of coding. Yeah, okay, so it would work the same.
Yes.
In SPSS. And
I haven't tried coding in SPSS for this purpose, but I strongly recommend if you do code this, use this algorithm, absolutely code it, because then you can make fine adjustments. You can check what your parameters are.
And then will it actually, then you can go through and check your groups? So will it spit out?
Absolutely.
Okay.
Yeah.
Okay, that sounds great.
And then also I do a lot of checks, such as like what other things I outputted, what are the top 30 responses. You can stop at each of the steps, just make a little line, output the table, and then continue to run it.
Mhm.
So
Okay.
I strongly recommend use coding for this algorithm.
Great. Okay. Thank you.
You can use like Python, you can use R as well.
And I'm assuming that this can be used quite easily with the different languages.
Yeah.
Malay language and
Yes.
Turkish language are the alphabet based.
Yeah.
And but of course, I'm not sure about the linguistic structure, whether any accommodation needs to be done to the Levenstein distance. And I think we will know this when these responses in the other languages are also analyzed using
absolutely.
this.
Yeah, so some of like anything that uses alphabet, you can use Levenstein distance, but the parameter like WT said may be adjusted a little bit depending on the characteristics of that language. So I would recommend the person who codes it will have some language ability of that response. So if it's a Turkish team, you need someone who speaks Turkish well to code it.
And I think that's the issue that we have with open-ended responses like this. It's difficult for us, for example, to help rough up when the German data comes in, for example. So you need someone who knows the language. And Cindy's doing the Hong Kong one because Cindy understands Mandarin, English, as well as the Cantonese style of Chinese as well. And that helped.
Yeah, that's a good point. Yeah, that's a good point because like in the Hong Kong data, most of those we have about 100,500 responses. Most of the responses are written in Chinese, about 30% in English, and some of the Chinese responses are written in Cantonese Chinese, like colloquial language. So it would really help if you have local knowledge of the language as well as like working knowledge.
So can I ask, Cindy, so when it spits it all out and you've got them grouped, how then do you develop the sub-themes and themes so that we can analyze?
Do you mean like the final 54 groups?
Yeah.
So that was dependent on the code book. So after it was spit out after 4 steps here, most of the responses are sorted. I email my co-authors and I say, this is what has spit out on the algorithm. Let's check and see if this is sensible. If anything that you think is a bit unsure, let's chuck it into a different group. So I have a group that's called 99. 99 means like, I'm not sure. Should this be in the irrelevant response group or should we sort it into the other group? And after everyone has given their input, then I adjust the step 4 parameters a little bit. And that would output it. So it would output directly into like 54 groups or something. So the Australian data generated 54 groups.
54.
Yeah, if I counted correctly. Yeah. Because the reason is you have to think back the data, it had 625 responses, but about 350 or 360 of them are unique responses. And after we have sorted through the 3 steps, there are 310 responses that have only 1 entry. Most of the responses are very diverse and very different, which is what we want in qualitative data. Yeah. They have some of the very unexpected responses or ways of expression that you don't think of, but are useful.
So in a very old-fashioned traditional way, I recently did some coding, and what we did is we just from whatever survey they used, I'm pretty sure it was just something very simple. They dumped it all into Excel, and then I was part of the coding where we read each statement.
Yeah.
We had agreed on a coding protocol and we gave it a number. And then another person did it, and then we got together and we saw how many similarities we had, how many differences. So we spoke about only the differences. We worked out the percentage of our similarities to ensure that the coding that we were doing was accurate according to the framework we developed to be able to code. And then we resolved any conflicts, and we actually reported in the paper how many, how accurate our coding was with the other colleague, etc. So are you saying that an instrument like this, I could have put all that data in, that would have done its magic that you've coded to be able to find common letters, is what I'm saying?
Yeah, so the Levenstein distance is mainly to pick up spelling mistakes. That's like the real reason why it's here. That's why also why it's not applicable to like Chinese characteristics. Because if someone spells like practice this, practice the verb form, the noun form, the practices, it picks it up. It's all in one group. And for your survey, yes, it will also work. So if your parameter was anything that has the word value, love, math, equations, put in one group, yeah, it will automate it. It won't be perfect in the first go. You have to adjust it finally. But once you've done it once, to the next data, it's pretty much ready.
So this is using Stata. So that's what we'd have to use, right, to do this analysis.
You can use any programming that uses a coding base, like Python, R, anything would work.
Okay,
Stata is just because I have it at home.
Okay, Wee Chong, so you want me to start to learn how to code. This is going to be very interesting for me. And Cindy, sorry if I'm taking up too much time.
No, that's good. Yeah.
I have another question. So with some of the statements, I would code to 2 different areas.
Yeah.
I would think they were 99 ones where I'd have to go and individually read them if there were, you know, we would say for example, we read statements, is this the classroom level? Is this a school level? Is this a system level? And we would look for particular words, exactly what you said you've done though.
Yeah.
But there was some that, you know, they've written such a detail, it wasn't like there's one word where we would code in different ways. Is it able to code in 2 different?
Yes, it is possible, but I did not do that in this one. So Wei Tong, I asked him if they have multiple responses, like what they think is most important. We took their first response, but if you want to adjust it so it has multiple groups, then you can literally set the parameters in there to show in group A and group B. And then you can also have another variable to say, identify all the responses that are present in multiple groups. So that is possible in coding, yes. You can even have it up to 10 groups. Yeah.
Aren't I lucky to have Cindy at Monash? I'll need to introduce you to some research assistants that we work with, Cindy. So I'm the lucky one.
Yeah. Monash is good. So that's also why I recommend everyone try coding section C qualitative data, because it will make your life a lot easier. Like the method you suggested, which is like one person sorting, coding it, the next person, is very valid. We also did that for class training. I did it with Julia. And as long as we're within X percentage of consistency, it's fine. But that still takes a lot of your time. You still have to read each entry. It's like the Wi-Fi data for Hong Kong. There's 1,500 for C1, then there's another 1,500 for C2, and then C3. And then if you analyze all 3 together, there's like 6,000 responses. And this is Chinese. You have to, it's like I don't have that much time to look through all of it. So if you can automate it a bit, it saves a lot of time.
But all the journals want large scale data anyway. So we have to start with a small scale to learn how to code and then use it. No, this is really good. Thank you.
Oh, thanks, Cindy. The reason why I wanted really Cindy to present today is because I do want to acknowledge that this is her baby, and she did it herself. You know, the thousands of data. I know that when I was in China, I was in this project with this project team, and the way they did their 2,000 pieces of data was to gather 35 of the research students into one classroom, and everybody do 200 or 300, and that can be easily done. But in Australia, at least, where we cannot find such a critical mass of research assistants, and Cindy was doing it herself. So I think it's a very good example of how cross-disciplinary knowledge is useful. I mean, she pieced this from genetics, studying DNA, and then how DNA structures change, and how you use the Levenshtein distance to describe differences in the genes. So I think it's a very interesting and promising way of proposing how we can use this to analyze open-ended data. Now, of course, Cindy is of no illusion that this is only the beginning, and she's very happy to receive feedback. But I am quite confident that if this code book is passed from one team to the other, the code book will become richer and richer, so that it becomes even more and more automated as time goes by. So feel free to contact Cindy and feel free to write with her or to collaborate with her as well.
Can I ask
anyone.
one question? Like,
Yep.
I do have a question for the team. So currently, most of the work is done on analyzing just the C1 responses, because if you remember that question, it's what are the 3 properties that we'll need if the pure makes you really good at math? So C1, we perceive it as the most important quality because that's the thing that they wrote the first. So right now, I guess it's like, should we analyze C2, C3 as well, or using the current framework, which is C1 versus C1 to 3? So that's what I thought the rest of the team, like, how would you go ahead and analyze your section C data for those 3 questions? And
something for us to think about, perhaps. But Cindy, will you be able to share with everyone your writing and your code once you have submitted the article to the journal?
Yeah, I think so. I think just right now, the code works well for English data and Chinese data. So I can write it out in a way that it's a basic framework, but it won't be directly inputable to yours. You need to make some fine adjustments as well. Like, it's not just simply copy paste. You need to make some adjustments, like the data that you collected from and stuff. But yes, yes. Once it's published, it is, yes, I can like make the code available, but I will note parts where you need to make adjustments. So the code will be like a few types. So you need to input the data, you need to clean it, you need to sort out the languages, then it's the 4 steps. The first 3 steps are in one loop, which is quite short, it's 20 lines, but the next step, which is the code book part, is quite long. For each one of them, there's a search loop inside the code, and you put the parameter. The parameter would be like what's in the code book.
So Cindy, Wei-Chong, is when Cindy does all this, is this the instrument that's used then to create that web, that web sort of thing that we had seen from Hong Kong? From
No, it's different.
Okay.
Yeah, I think that one is just looking at the where it falls on the 4-point scale.
Okay.
Section B. Yeah.
Yep. This is section B.
Yeah, section B.
Hi, we have the youngest member.
I can see a gorgeous little baby I haven't seen in a while.
Thank you, Cindy. Thank you. Can we use this opportunity as well just to have Ralph and Jody introduce themselves to us?
Well, shall I start?
Yeah.
I wanted to give it ladies first, but as there is a silence, I can go ahead. Well, good afternoon, everyone, or good morning from Germany. I'm really sorry. I apologize for that you have to look at a black screen, but my laptop seems to have broken down this morning, and I don't have an internet connection to my other computer. Well, my name is Ralph Ahrens. I work at the University of Education in Freiburg. I've been in contact with Wei-Chong and the group for some years now. My main research interest is the study of teachers' beliefs and values. And at the moment, I'm trying to, well, let's say, do correct me, Wei-Chong, if I'm wrong. I'm trying to rejoin the group after a little pause, and I'm happy to see Yüksel here this morning. We've established a contact, and we're trying to put forward a proposal to the German Academic Exchange Service and try to start a cooperation here so that we can contribute some sort of research on values alignment, which we will try to do so in some time. Yes, thank you.
Yeah. Thanks, Ralph. Jody, I think you can see Jody's name as Jody Spivers, and that's Jody Hunter from New Zealand. I'm not sure whether she's there.
Hi there. Sorry, I'm just in the car, so haven't got my video on either.
No worries.
So yeah, So that was very interesting. Thank you, Cindy. Because I'm trying to think about. We've got a large project as well at the moment. That's we'll be looking at coding a large amount of data as well. So that will be interesting to look at that. So my research I've been very interested in is in New Zealand, and my own cultural heritage is a person of the Pacific. So my family is originally from the Cook Islands. And one of the things that I'm very interested in looking at is how the Pacifica students' values and how teachers can draw on those values, because Pacifica people come from a culture which is very collective and draw on collaboration and collectivism. And so I'm very interested in looking at how teachers can use that as a strength in the classroom. So that's kind of the research that I'm working on at the moment and looking at, and then also, looking at the other students in New Zealand and their values as well. Yeah, thank you.
Thanks, Judy.
Yeah,
thank you.
I did. Cool. Yeah, I have just had an article published on values. Just it's in press at the moment in International Journal on mathematics and science teaching, I think it's called. So it took a long time to get published, but it's on looking at algebra and the cultural. Oh, cool. Penelope's just put it into the chat. Yeah. So thank you.
Very good.
Okay.
Congratulations. And of course, there's a bit of a relationship as well. Julia, whom you know, did her master's research with Jody in New Zealand. So there's a bit of that relationship, Jody, Julia, and myself. So it's one big family, so to speak. And Ralph, you yes, it is not about you rejoining, because we have been quiet for a while in the first 6 or 7 months this year, because there was no conference, and of course we couldn't meet. So it's only recently in the last 2 or 3 months that we decided that this looks like it's going to be a while, and we may as well try to do some virtual meetings over Zoom. So yep, it's nice to see you, or to hear from you today, definitely. Is there any updates or anything to share from anyone in the group? Hi, Rosalind.
Unmute myself. Sorry, I was listening to Cindy's presentation just now about how she coded the responses from the section C in the Wi-Fi question. I just read it today, and I tried to make sense what was she talking about. Then then it just hit me, and then I was just curious, like it only applied only English and also Chinese languages, right? Because of the similarities. Is it, Cindy?
No. I was saying I've only tried it on the English and Chinese, because
okay. So you're saying that if we're going to use it in another language, so we should put another parameters. What do you mean by that? Like,
yes. So like other languages, if you use an alphabet language, it would be very similar to the English one. So the 4 steps should all work. But the parameters that you need to change would be, say, the number of letters that it needs to be. Because in English, anything that's 2 letters or less is pretty meaningless. It's preposition, or it's his or her or I am.
yeah.
And I don't know what language that you want to analyze and what the properties is. The other parameter you might want to change is the Levenshtein distance. In English, a Levenshtein distance of 3, and for words more than 3 letters, it's quite meaningful. But for another language, you might need fewer Levenshtein distance, or you need more. But that is entirely dependent on the language characteristics that you plan to analyze. And I give that example is because, like Chinese characters, Levenshtein distance is absolutely meaningless. It does not work. And I haven't found an equivalent edit distance that would pick up Chinese differences. So in order to do so, someone might need to input all of the Chinese words or Chinese characters into like a Stata or something, and generate an algorithm to work out the distances based on the meaning. But currently that that I'm aware of.
Okay, all right. Thank you so much, Cindy. I think it will be applicable to Malay as well, because we use a lot of alphabets as well. But
Yeah, I think it will work because it has an alphabet system. Yeah.
yeah, all right. Thank you.
Can I
I
speak?
think the Malay language will have to be,
Sorry.
sorry.
Yeah.
Whatever.
Thank you for sharing, Cindy. Yeah, I need to think a little bit about this analyze, because Turkish is quite different from European and Chinese language.
Yeah.
I have no familiarity with the Chinese language.
Yeah.
I have no certainly, but I have a familiarity with European language, German and English, such as.
Yeah.
While a sentence is usually formed in European language, the subjects come first, followed by the verb. But we too in Turkish comes to a verb at the end of the sentences. Is it possible to find words like in English, for example, nutritional and nutrient, and get them in the same group? You have to think about it. Thank you.
Yes, yeah. So I think for the order of the words, orders of word in a sentence, that doesn't matter so much because the algorithm either picks up identical or like slight minor changes. So whether it's before the verb before the noun before the word, it doesn't matter so much. So I think it should work for Turkish with some minor tweaking.
Okay. Okay, thank you.
Oh, one quick question. Have you used any automated system in NVivo? Because I know I do all my coding in NVivo for the qualitative, and I know there's an automated system in there, and you know you can do word clouds and things like that. Have you tried any of?
So before I rolled up this algorithm, I did try NVivo, and I haven't found anything that really did what I want. It was able to get the frequency count, but other than that, I wasn't able to really group it in a very meticulous way. Like it might be able to do like a general group, but then nuanced stuff, it was a bit difficult. Like for example, content knowledge and knowledge is different groups because one is related to the general knowledge of things and one is like math knowledge. Mm-hmm. So I wasn't able to separate these responses. But if you use a coding system and this algorithm, you'll be able to select certain characteristics and separate them into 1, 2, or 10 groups.
Mm. And like, so the one student response, could that be coded into say multiple themes, or does the SPS, the version you on, was it Strava?
Stata, sorry.
Would that just code a single response as a single?
That would be your preference. So for my setting, I code it to one group. Each response will be in one group. But like Penny said, some of the projects, you might want it to be in multiple groups. That's possible as well. And you can set another parameter saying that any responses that are in multiple groups, list them.
Mm-hmm. Yeah.
Or you can even list like any responses that are in 3 groups. Tell me what they are.
Mm-hmm. And then could you get it to spit out? So subject 1 had X, Y, Z group. Subject 2 had, okay.
Yes, absolutely. Yeah, you can output the table however way you want, like with the customization you want, as long as you have correctly coded the labels or the parameters.
Mm-hmm.
So there's a lot more flexibility in how you want to present and see and sort and categorize the data.
Mommy?
Yeah. This is the other one.
Hi, Frankie.
Say hi.
Hi.
Hello, Frankie.
Thank you. Thanks, Cindy.
You're welcome. I forgot to turn off my mic.
I guess there's something else that Cindy may want to share with us as well. For those of us who are collecting bilingual data, and yet we are reporting in English language journals and reports or conference papers, there is sometimes the need to translate non-English language and data into the English equivalent. And in Cindy's case, when she was analyzing the Hong Kong data, some of the students were putting in English language responses, some were putting in Chinese language responses. And these are come in thousands of responses. And of course, one of the things that we want to do first perhaps is to think about translating all the Chinese language responses into the English equivalent and then analyze them together. Cindy finds that there's an even easier way of doing it. So Cindy, do you want to share with us?
Yes, so do you mean like after they're sorted in groups and then you just look at the group name? So yeah, So the way you do it, after the four steps of analysis, for Chinese is only 3 steps, you basically come up with like 50 groups. So all you have to do is translate the 50 names as opposed to like 5,000 responses. And that's a lot less work.
So I think her advice is to translate, to analyze the different groups by languages first.
Yeah.
And then you pull them together by looking at the categories or the groups rather than looking at the individual responses.
Yeah, so that has 2 benefits. One is like Wei Tong said, it saves time. The other is it's more accurate. So if you make a mistake somewhere up the chain, you can go back and check, rather than if you just translated everything before you have done any of that analysis, you have to go back to your translation and find 1 line out of 5,000 responses. What mistake did I make? And the other issue is I did try translating C1, 1,500 responses. And by the time I got to like maybe 1,200, I can't remember how I translated some of the stuff. I'm like, this is not consistent. This is not good. So for me, it was very difficult to maintain my consistency in translation.
I guess the question that Cindy asked is useful for us to think about as well. As you know, in section C, we asked the students or the respondents to actually say, what is the most important thing to you? Followed by what is the second most important and what is the third most important. So this is what she meant by C1, C2, and C3, the first choice, second choice, and third choice. And she has 2 sets of analysis. One, which is to prioritize what is the first choice and analyze it. And she also analyzed a second set where the first choice, second choice, and third choice are pulled together and analyzed separately. So I guess the question is, does it matter, or what difference does it make? Or some of you may be thinking about whether there's any difference between a first choice, second choice, and third choice. Maybe there is, maybe there isn't, and if there is, do you want to allocate weight to each of these frequencies? So perhaps the first choice will have 3 points, and the third choice will have 1 point. Or does it matter? Sometimes people may not really allocate any difference to first choice, second choice, or third choice. And in Julia's latest work, for example, for a PhD, she circumvented by, instead of asking people to, the respondents to choose first choice, second choice, and third choice, what do you do, Julia, with your allocating of values?
So what was this? Sorry, which values was this?
For your, I think for a PhD study, where you actually get people to move things into categories.
Oh, okay. Sorry, I've been on mat leave for the year. I'm trying to remember what I've done now. So they could drag. Is that the one you're talking about, where they drag the?
The dragging, yeah.
Oh, okay. So in Qualtrics, they could choose their top 3 values, but they'll just drag them into the box. Yeah, I think that's what you were. I think that's what you. Yeah. Yep.
So in Julia's case,
I think most valued and least valued. So then they drag them in the top and drag them in the bottom, because then there was no. I was thinking about, is there any real statistical difference between first, second, and third? So I would just say these are the top ones, and this one is the least value, and I sort of analyzed it like that.
And she was using the Qualtrics software. I think SurveyMonkey may have the same feature as well. So instead of the respondents actually ranking the choices, is simply to put them into categories themselves. So that's another way of going around the question. Any thoughts, comments, suggestions? or any news of any research grants? Hey, Masita.
Oh, sorry, yeah, before you talk about your research grants, because I'm trying to understand section C and looking at the questions like, how is this related to maths? And then Lynn kindly explained to me that this is about values. So which is something new, very new for me. That's why I need to bring in my other team members in terms of explaining it to me. So how, that's the thing. How do you categorize everything and then relate it to maths in terms of in terms of this questionnaire, especially because if it's what I find important in maths learning, how do you link these values into the maths learning? Is this already been analyzed, or am I too late to ask this question?
No, you're not too late. In fact, I think it's a very good question. It's a valid question to ask. I think most of us come from a tradition where we believe that doing well in maths or learning maths is not just about learning the knowledge and the skills, but also the sort of things that that is important for you personally. So if you think, for example, if you think that it is important to practice, and practice is important, then that will help, or that will explain why you as a teacher or as a student act or behave in particular ways, supporting your valuing of practice. Or if you do not practice, if you do not value practice, it might help us to explain why, as a student or as a teacher, you shy away from activities or actions or decisions that embrace practice. And I think that will link very well to the next thing that we will talk about next month, which is I'm quite interested in talking about how we can feed into and how we can contribute to the what I see as a evolution of maths education systems in the aftermath of the COVID-19. More and more emphasis on the teaching of values like global competence, resilience to students through the different subjects, including maths, and how we can actually make use of values theory to help maths teachers teach and inculcate such values through the teaching of maths. Of course, those values may not contribute to maths learning and maths scores. Those are more values about having resilience in life. Empathy. Empathy is one of the values that are being propagated by PISA 2018 in the latest report. So those are not values that will help a child do maths better, but certainly I think more and more governments are interested in education systems and curriculum reform to actually think about how we can help children cultivate these attributes through literacy, through numeracy, and through other subjects, because it's going to be quite difficult to teach these as a standalone subject. Students will not be very effective. I think we all know that.
All right, thank you very much.
Thank you. Okay, I guess it's in a way it's 5:30 in Melbourne now, so it's time for some of you who need to go for meetings and for lessons and for lectures to go. But as usual, I'm available to chat with anyone after this is over. So feel free to go for your other commitments. But definitely, if you want to stay on, we can continue to chat for a little while longer. Thank you, Cindy, once again for your explanations and for your sharing.
Thank you.